Welcome to the video lesson for multiplying and dividing rational expressions. I want to start off this video lesson by repeating what I think the most important thing for you to keep in mind when doing rational expressions is, and that's you already know so much about rational expressions because everything you know about fractions applies to rational expressions and everything you know about polynomials applies to rational expressions. This is by far the most important thing to keep in mind because if you can keep this in mind, you can do any rational expressions problem because you have extensive experience with fractions and you have a good foundation with polynomials. There's still more that you can learn, but you have a good foundation on the basics of polynomials. So let's remind ourselves, how do we multiply two fractions? So here I have the problem 3 halves, or 3 over 2, times 2 over 7. And I remember that in order to multiply two fractions, I'm going to multiply numerator to numerator, denominator to denominator. So this is going to be equal to 3 times 2 over 2 times 7. And notice at this point I have a 2 in my numerator and in my denominator, and I have multiplication happening. It means from the last video you watched, you can cancel those out. And you end up with 3 over 7. To multiply rational expressions, we're going to do the same thing. So multiply numerator to numerator and denominator to denominator. And of course, after we do the multiplication, we need to simplify. I'm going to add one step in here for rational expressions, and you shouldn't be surprised by this step, and that's before we do any of this, we need to factor. This should seem similar to our rules for addition and subtraction, where it was exactly the same, except for I added the rule to factor in the beginning. Let's take a look at an example of x over 2y squared times y over z. There's nothing to factor here because I don't have any addition going on in any of my numerators or denominators, which means I'm just going to multiply numerator to numerator and denominator to denominator. And I get yx over 2y squared times z. I notice I have a y in my numerator and a y in my denominator, a y squared in fact. And remember, I can cancel those out since there's only multiplication happening to get x over 2yz. Division is going to be very similar to multiplication. The first step is going to be to factor. And now for division, we have to add one more step, and that is flip the second fraction. Finally, the last step is to multiply. So here I have an example, x squared plus 2x plus 1 over x squared plus 5x plus 6 divided by x plus 1 over x plus 3. And now I'm hoping that nobody is tempted to try to cross cancel or just cancel these 2x squareds because they realize there's addition happening, so we can't do any canceling yet. We need to change it so we have multiplication happening. And the way we're going to do that is by factoring. We're going to factor by starting by setting up my diamond problem. Top I'll put a 1, the bottom a 2. I ask myself what two numbers multiply to 1, add to 2. It's 1 and 1. This becomes x plus 1, x plus 1. My second diamond problem is 6 and 5. I ask myself what multiplies to 6 and adds to 5, and that's 2 and 3. So I get x plus 2 times x plus 3. And now I'm going to go ahead and change my division sign to multiplication and flip my second fraction. You'll recall that the flipped version of a fraction is called its reciprocal. So I get x plus 3 over x plus 1. And now I'm multiplying, I said x plus 1 and then wrote x plus 3. Now you see, because we're multiplying both x and 3. So I can think of them as a unit, x plus 3. And same with the bottom, it's the whole unit, x plus 1. I'm not just multiplying x, I'm not just multiplying 1, I'm multiplying x plus 1. I can think of x plus 1 as its own entity. And now I notice that I have some things I can cancel out. I have x plus 1 on the top here that's multiplying, x plus 1 on the bottom here that's multiplying. Notice I'm not canceling out x and 1, I'm canceling out the whole thing. I'm canceling out x plus 1 because that whole unit, x plus 1, is doing multiplying. The x isn't just multiplying, the 1 isn't just multiplying, the whole unit, x plus 1, is multiplying. I also have x plus 3 and x plus 3. Means when I do my multiplication, all I'm left with is x plus 1 over x plus 2. That concludes my video for multiplying and dividing rational expressions. Please ask any questions that you have in class or send me an email.